Welcome. In this section, we are going to discuss about ERC20 and how you can create your own token and deploy on live blockchain. So let's get started. So before we understand ERC20, let's understand what is token. So token is a fungible virtual good that can be traded. It is similar to share in a company, and Ether is a native token of Ethereum blockchain. So suppose you are running a business and you distributed 100 tokens, and if I have 10 tokens distributed by you, that means I have 10% share in your business. Now, when you think of creating a token for your business, you need to follow some standards while writing the smart contract. Ethereum has standard protocols to define tokens. ERC20 is one critical innovation in the creation of Ethereum-based tokens. ERC stands for Ethereum Request for Comments, and 20 stands for a unique ID number. Differentiate this standard from others. ERC20 is a standard technical specification to implement a token on Ethereum blockchain. So it is not a technology, it's a set of commands that a token should implement. The ERC20 protocol standard contains 6 basic functions and 2 events that any token should implement to enable trading. Each ERC20 smart contract needs to implement all these 6 functions and 2 events to be able to implement fully compliant ERC20 token. Here you can see I have an interface with 6 functions and 2 events. Why we use interface? Because a standard interface allows any tokens on Ethereum to be reused by other applications. The interface is the non-deployable contract. You cannot deploy this as a contract. In interface, you will not have any functions fully implemented. Like here, you can see we have just functions defined, but we don't have function body or any piece of code inside the function. So, what is the use of interface? Interface gets inherited by a smart contract, and then the contract has to fully implement all the functions. Here, ERC20 token contract inherits ERC20 interface. We can only deploy ERC20 token contract if all these 6 functions and 2 events are fully implemented inside ERC20 token. If ERC20 token contract does not implement any of these functions, it cannot be deployed. And so, using interface, we can ensure that we are implementing all the required functions and events and create a fully ERC20 standard token. We will discuss all these functions and events while creating our own ERC20 token in next following lectures. That's all in this lecture. I will see you in the next lecture. Welcome. In this lecture and next few lectures, we will create our own ERC20 token and deploy in Ring-B network. So here I have created a Solidity file with standard ERC20 interface. So you can see it is defined as interface, not as contract. So you cannot deploy this, but any contract can inherit this ERC20 interface. You can see no function is complete, and that's why it is called interface, and you cannot deploy this contract, but any other contract can inherit it and use all these functions listed here with events, and that other contract can be deployed. Here total supply, it returns the initial quantity of rolled out token. When we will create a token, we have to give a number how many tokens we want to roll out, and this is the getter which you can use to get the number what was supplied initially. Another function is balance of. It returns the number of token held by any particular address. So you will just pass the address and it will give you the number of tokens held by that address. So you can see returns is the balance and it's unsigned integer. It's a number. Then we have another function transfer. The arguments are to and value. To is the address of to account. That means this is the recipient account, and value is the how many tokens this recipient account will receive, and bool is just to return successful flag, that is true. Once all the lines of code run successfully, then this function will return true. So these 3 functions are the basic functions you need to have to create a token and transfer from one account to other account. Now there are three more functions which add more functionality to the ERC20 token. So approve function. Approve function, you can see here there are two arguments. First is address, it's a spender, and second argument is value. So what is spender and what is value? Definitely value is the number of tokens. And then what is the spender? So approve functions approves a spender to use its own token. For example, if I am the owner and I have 1000 tokens, using this function I can give you authority to use all of my 1000 tokens or less. So if I give you authority to use my 20 tokens, you can use this transfer from function to transfer those approved tokens to your address. So from here the arguments from is the account who is approving and to who is receiving that token, and value is the number of token. So using approve function, one account can approve other account that the other account can use first account token, and when it is approved, transfer from function can be used to transfer the approved number of tokens or less from the approving account to the spender account, and once everything is successful, this function will return true. Then comes the allowance function. Allowance function has two parameters, owner and spender, and it returns remaining. So what is this allowance function? So this is the getter function. This is the getter function to know the number of remaining approved tokens. So suppose I am the owner of 1000 tokens. I approve you to use my 200 tokens using this approve function. Now if you call this allowance function, it will return you 200. So owner is my account because I have approved the tokens. Spender is you. Now if you use the transfer from function to transfer some 50 tokens from my account to your account, I have approved you 200 tokens, you transferred 50 tokens from my account to your account, then remaining is 150. That's what allowance will return you. Allowance will return you how many tokens are remaining which you can use or transfer from the approving account to your account. That means from the owner account to spender account. And there are two events we have to use. So transfer event is used inside the transfer function, which logs the transfer function activity like from account to account and how many tokens were transferred. Another event is approval. It is used inside approve function to log the activity of approve function. That is, who is the owner, who is the spender, and how many tokens are approved, which spender can transfer from owner's account to its own account. Hope you understood this ERC20 interface. In next lecture, we are going to inherit this interface and start writing a smart contract to create our own ERC20 token. That's all in this lecture. I'll see you in next lecture. Thank you. Welcome. As you know, to implement ERC20 token, we need all these functions and events in our contract. We can just inherit this via contract and we can use all these functions and events. So how we can inherit is, we can just write contract, then we have to give our contract name. Let's give it as my ERC20 token. And then we have to write is, and then we have to write our interface name. So this is IERC20. Then you can open the brace. That's it. So now we can use these functions and events. So first thing what we are going to do is we will define some state variables. So we need a mapping state variable where we will store address and number of tokens. So key will be your address and value will be your number of tokens. So it's like this. So initially the mapping will have one entry when you deploy this contract, and that entry will be for the creator of this contract, and the number of tokens will be like the initial supply. Suppose I am creating this contract, this mapping will have my address as a key, and suppose if I am rolling out 10,000 tokens, so my account will have 10,000 tokens. Later I can transfer that tokens to you, then this mapping will have your entry as well and number of tokens you received from me. Now there are three variables you need to define as per ERC20 standard, and these are optional, but as a best practice we should define these. So these are name, symbol, and decimal. Name holds the name of the token. So first we can define it as a string public name. So this is the name of our token. So you can give any name within a double quote. So let's give BLK training, or you can give your name, whatever you want. Then the symbol, like Ether has the symbol of ETH, right? So you will define the symbol of your token. So let's define, and again we can give the any name here. So let's give it BLTK. Now we have a decimal. So decimal is used to specify the number of decimals token can use. Like I can transfer you 10 tokens or 10.23 tokens. So that time you will define decimal as 2, because you have 10.23 is a 2 digits. But here we don't need to define any decimal, so we will just take it as a 0. We will use the whole number. So let's define unsigned integer. Now let's define a variable which will store the initial supply of the tokens, how many tokens we are rolling out. So it will be unsigned integer and it will hold the initial supply. So let's define, we can name it as total supply. We also need the address of the token owner. Like if I am creating this token, then I should store my address, because this mapping will store that address and the number of tokens. So we need a variable where we can store who is the creator of this token. We need to store creator's address who is creating this token. So we need a address data type variable, and this will store creator's address. So let's give the name as underscore creator. So now either we can assign the number at contract level, or we can have a constructor. So let's create a constructor. Inside the constructor, you can store the address of the creator of the token, and that would be your message.sender. So let's write underscore creator equal to message.sender. And then we will assign the number of tokens we want to roll out. So that is the field is total supply, and we can assign some 10,000 tokens or 50,000 tokens. So now once we have the creator address and number of tokens, we can create an entry in the mapping for the creator address and the number of tokens, that is total supply. That means right now contract owner holds all the tokens. So we can write balance is creator equal to total supply. So here we are passing the address as a key and the value as total supply. So this mapping will have one entry, the creator address and number of tokens. So let's deploy this. If we can deploy it, one thing you can test it, there is a ERC20 interface. If you are deploying it, it will give you the error. And again, if I want to deploy this, my ERC20 token, I would not able to deploy it because I have not implemented any functions or event. But if I just comment it out all these functions and events, I would be able to deploy this contract. That's all in this lecture. From next lecture, we are going to write these functions and events. I'll see you in next lecture. Thank you. So here we have 6 functions. So let's start writing. The first function is total supply. So you can just copy this line from here, function total supply till this semicolon, and you can just paste it here in your contract. Remove this semicolon and then open the brace. Now we have to write the code. This function is just a getter of this total supply. So if you don't have this total supply as a public define, you can actually define this total supply as private, and you can use this total supply getter to get the initial number of tokens. So we can just return here total supply. That's it. You implemented one function. Second function is balance of, right? So let's create second function. Again, copy it from here and then paste it in your contract. And remove this semicolon, open the brace. That's it. So now you can see we have to pass the address and it will return you the balance. That means where we are saving this, we are saving the address and the balance in this mapping. That means this is the getter of this mapping. So we can write here return mapping name, and then we can pass the address, that is your underscore owner. That's it. You implemented your second function. Now the function which you will use most of the time is your transfer function. So third function here you can see is the transfer. Let's copy it and paste it here. Remove the semicolon, open the brace. This underscore 2 is the address which will be receiving the token and how many tokens it will receive. This is underscore value. Again, you can choose whatever name you want to your parameters. Okay. And this bool will return true if everything goes well in this function. So what will happen? If from account transfers some tokens to 2 accounts, there will be a new entry in this mapping. And how you can write that entry for 2 accounts is when 2 account will receive the token. Suppose 2 account is receiving the 10 tokens from account. then the number of tokens of two accounts will be increased by 10. Initially it will be 0. So you can write is that balance is underscore 2 plus equal to value. So first time 2 account will have value of 0. So when from address transfer suppose 10 tokens, this 10 will be added to 0. So there will be entry with the 2 account address in your mapping with value 10. Next time if again it gets suppose 50 tokens from any other account, that 50 will be added to 10. So that's why we have used plus equal to. So every time it will add to the existing value. So here 2 account has received 2, so we have increased the number of value. Now we have to decrease the same number of tokens from the from account, and from account here is the message.sender who is calling this transfer function. So let's write. Now we have this event which we have to use in this transfer function. So let's copy it and paste it here in function transfer and change this event to emit. So that's how you will emit the event. Now we don't need these data type. You just need to pass what is from, what is to, and what is value. So from is message.sender. And then again remove this address index from here as well, and 2 is 2, so 2 account is underscore 2, and then for value also just remove this data type. You don't need the data type. Our emit is ready. Everything is done. We have to return this success, right? Return true. So our transfer function is ready, but we can add one check here. So we want to execute these lines of code only if the number of tokens, like this value, is a valid number. Suppose somebody is trying to transfer 0. If he enters 0, it should not execute these functions because you cannot transfer 0 tokens from one account to other account. So it must be greater than 0. We should also check that whatever number of tokens the from account, the caller of this function, wants to transfer, he has that in balance. Suppose caller wants to transfer 10 tokens, and if the caller has only 5 tokens in its balance, he would not able to transfer, right? So let's put the require statement, and how we can write is value should be greater than 0 and balance of message.sender should be greater than equal to value. So with this, we are actually done with these 3 functions: total supply, balance of, and transfer function, and also we have used one event. So we can actually deploy it and test it, but like we will not able to deploy until we implement all these 6 functions. So what we can do is, just for our testing purpose, we can just comment these functions which we have not yet implemented. So let's commit this approve, then transfer from, and this allowance, and also this event. Now if we want to deploy it, and let's deploy it on JavaScript. So we have the 5 accounts here. Select the first one as we can take as an owner, and we have to deploy this contract, not ERC20. So select this my ERC20 token and deploy it. Now we are able to deploy because we have commented those functions and event which we have not yet implemented. So the creator of this token is, the address is starting with 0xCA35B, and you can see here this is the first account. And we can also see how many tokens this creator has rolled out. So that is the total supply. So total supply, if you click here on the total supply, you will see 50,000 tokens he has rolled out. And the second function is our balance of. So if you just check who has this 50,000, so first entry is the owner. So right now owner has the 50,000. So what we can do is we can just copy this, and if you just paste it here, balance of, you will able to see that the owner has all the 50,000. We saw that how this total supply works, how this balance of works. Now let's do this transfer. So right now all the tokens are with this owner. So let's transfer these some tokens from this owner account to some other account. Let's select the 5th one and copy this 5th. But who will run the transaction? The person who has the token, like the owner, will run this transaction. So owner wants to transfer to this account how many tokens? Suppose 5,000 tokens. Okay, so there are 2 arguments, 2 account, and the number of tokens the owner wants to transfer. Click on this transfer. Let's see what happened in our Windows console. So our transaction is successful, and we should also see the event. Let's see if we are able to see the event or not. So we can see the event transfer. This is our argument, this 2 account 0xD870, where we are transferring the token, and this second argument is number of tokens. So in our emit at 0, it's a message sender 0xCA35, 2 is at number 1 and the value is at number 2. So this is a from account, to account and number of tokens, and you can see the here as well. So event is working. Now let's check the balance of where we have sent. We have transferred token to the 5th account. Let's copy it, and if you go to balance of, here you can just paste it here and click on this balance of, so you can see the 5,000 tokens are there. Now if you check the balance of owner who has already transferred 5,000, earlier this owner had 50,000 as a total supply. Now if you check the balance of the owner, it's 45,000. So our all these functions and event working. Now in the next lecture we are going to implement rest of these functions and the approval event. Welcome. In this lecture, we are going to implement rest of the 3 functions: approve, transfer from allowance and the event. So it will complete our ERC token smart contract. So since we have commented out all these functions, let's remove the comment from approve, transfer from and allowance function, and then we have this event. Now let's first write this approve function. Let's copy the function approve line, and here we can just paste it in our smart contract. Remove this semicolon and open the brace. As you know, using this function, one account can approve token to other account and the other account can transfer it to its own account. So here the message dot sender will be the first account who is approving it. So this function will be run by the account who is approving its own token to be used by some other account, that is called spender. So here the other account who is getting the approval is represented as spender account. You can name it anything for these variables. You can name these variables as you like, but just understand first argument is second account which is getting the approval, and the second argument is the number of tokens which are going to be approved, and then it will return the flag success. You can have external or public. Inside function, we will first make sure that value is greater than 0 as we did it for the transfer. So let's copy this require statement from here. So we are making sure that we are not playing with 0 token. Okay. So here value should be greater than 0, and the balance of message sender is definitely whatever this message dot sender approving account is trying to approve, that account should have the enough tokens. Now we need a mapping table which can store approving account address, then spending account address, and also the allowed number of tokens. So we want to store 3 things. So like this mapping, here we have key as an address and the unsigned integer 256 is the number of tokens this address has. Now we need another mapping. This mapping is for approval. How we can define this mapping is mapping. This is the first address. This is the address of the owner or approving account. Now this account will approve tokens to spender account. So you have another spender account, and then we need to store the number of tokens which are approved. So we have first address, second address, and number of tokens approved by the first address. But this is not the correct syntax for mapping. So you will put a mapping here. So we are actually creating a mapping inside a map, because this key, this first address, can approve tokens to 2 different, 3 different or multiple accounts, right? So it may be like this. Suppose owner is 111 and then it approves to account 222 how many tokens, and it approves suppose 10 tokens. Again, the same account can approve tokens to account 3333 and suppose 20 tokens. So this is how it will be written in the mapping. Okay. Now we have to give the name of this mapping. Let's give allowed. So if you pass the owner address and the spender address, this mapping will give you the number of tokens approved by the owner. So we can write here is mapping name allowed, and then we have to write the from address, the owner address, or you can say the approving address, that's a message dot sender, and then there will be another key because we have a mapping inside the mapping. This is the key of first mapping. This is now we have the key for second mapping, and the key for second mapping is the spender. And if you pass these things, the mapping will represent the value. So this is the value, and what value we are assigning here is whatever we have at the parameter. So how it is working here? So whenever message.sender will call this function, there will be one entry written. Suppose this value is 20. So in that mapping, allowed mapping, we will have one entry, message.sender address, spender.sender address. In that mapping, we will have 20 token as a value of key spender, and this spender will have the key of message sender. And then we have one event for this function. So that event is approval event. So copy this event and paste it here. Change this event to emit, and we have to remove all these data types. And who is the owner? Owner is message.sender, and these are already defined here. Spender is spender, value is value. So this is our emit, and then we will return true. So our approve function is ready. So we implemented 4 functions: total supply, balance of, transfer, and approve, and both of the events. Now we have to implement this function transfer from. It's not sequential. You can actually implement any function first, and then you can take any other function second. So now we will write the transfer from function. Copy this and paste it in your contract. Remove this semicolon, open the brace. Transfer from function is similar to transfer function. Only difference is in transfer function only one mapping is getting impacted. We are reducing number of tokens from the from account, and we are adding the number of tokens to the to account, that is balancer, that is this mapping. But in transfer from function we will do this as well, but we will have to update this mapping as well. So actually what we can do is we can just copy the codes from this transfer function. Let's copy these code and paste it here. Now we need some changes, right? So value should be greater than 0, and the message.sender, that is the from account. Since from is a parameter, so you don't need to use the message.sender. So you can actually use this from account should have the balance greater than equal to value. And also there should be one more condition, that whatever number of tokens are getting transferred from account to account, those number of tokens should be allowed first. For an example, if from account has allowed 50 tokens to address 2, now 2 is trying to transfer those approved 50 tokens to its own account, then that 2 account may write here 60, that is not allowed. Only 50 tokens are allowed. So we have to check here that whatever value we are passing should not exceed the allowed number of tokens, and allowed number of tokens will come from allowed mapping. So this is the complete condition check. So value should be greater than 0, and whoever is transferring this number of tokens should have the balance, that is from the balance mapping. The balance mapping which stores the address and the number of tokens that address holds. And then we have to also check the allowed mapping. The whatever number of tokens we are trying to transfer here, those number of tokens should be first approved, and that approved tokens are in allowed mapping. So we will do the same thing. Once the token will be transferred, we will add the number of tokens to the to account. We will reduce the number of tokens from account, and then we will also reduce the allowed number of tokens because we have already transferred. So either it will be 0 or less than the total number of allowed tokens. So we can write here allowed from to, and we do not have any events, so we can delete it. So what is going here is, so suppose the approval was happened for 50 tokens. Now the to account is trying to transfer 40 tokens from those 50 tokens. So 40 tokens will be added to the to accounts, 40 tokens will be reduced from the from account, and also 40 tokens will be reduced from the allowed pool. Now the to account will have only 10 tokens approved in allowed mapping. So next time that to address can transfer all those 10 tokens or lesser than that. We have last function called allowance, and this is the getter of this mapping. So let's copy it from here and we can paste it here. Remove this semicolon. So this function is the getter of allowed mapping. So we can just write return allowed, and this is your from account who is approving, so owner and spender. That's it. So as we took the example here, so suppose the approve function approves for 50 tokens. So after approval, if you call this allowance, it will give you the 50. So it will return 50 as a remaining. So remaining is unsigned integer. It's a number of token in this mapping. If you transfer 40 tokens, again you will run this allowance. It will give you 10, the remaining number of tokens in the allowed pool. So we have implemented everything. So we can now deploy it and test it. So in next lecture, we are going to test this complete smart contract, which is going to give us a fully ERC20 compliant token. So that's all in this lecture. I'll see you in next lecture. Welcome. So we have created our smart contract, ERC20 smart contract, to create our own coin, and we have a coin symbol BLTK. So let's deploy this contract on Rinkeby network. Make sure you are logged into your MetaMask. You have selected Rinkeby test network, and then change this environment to injected web3, and you can actually refresh this browser. So reload this browser, that account should come here. So if you go to run now, so injected, the account number is 00D2AC3 ACE. So the account is starting from 0x00D2. So we have the first account from the Rinkeby network. So this account, the first account, is going to deploy this contract on Rinkeby. So this account will be the owner and creator of the token. So here you can see the message.sender. So this first account will be the creator, and it will have all the 50,000 tokens, and that we will get in this mapping. So first let's deploy this on Rinkeby network. And when we are deploying, we don't need to pass anything, because you only need to pass something at the time of deployment if you are passing something in constructor as an argument. So we are not passing anything here. We don't need to pass at the time of deployment. Just click on this deployment and make sure the account you are choosing to deploy has some ether, because that account will have to pay the gas for the deployment. So you can see the gas fee here. So let's confirm it, and it will give you a Rinkeby link. Click here, and after a few seconds we'll see the transaction details. So our smart contract is deployed successfully. So this is the from account, and this is the contract address. So if you click on this contract address, you can see this is the contract creation. But where is the tokens, right? So what we need to do is, if you go to this MetaMask, you have to add a token here. Since this is a custom token, you will have to go here in this menu item. There is an option to add token. So you have to go to this custom token. But before that, we have to get this address. You have to copy this contract address. Copy this contract address. Go to MetaMask, click on menu, click on add token, click on custom token link, then paste the token contract address. You will see automatically it will take the BLTK token symbol here. Now you have to click on next, and now you have to click on add tokens. So you can see the account 1 has all the 50,000 tokens. Right now, test all these functions one by one. So first is your total supply. If you click on this total supply, it will give you 50,000. That's working fine. And now balance of. So balance of, what we can do is we can check the balance of creator, because this is the first account who has all the balance, right? So balance of, if you can just copy and paste that address of the creator in this balance of function, it will give you the 50,000. The third function is your transfer function. So let's transfer. So this owner can transfer some tokens to other account. Let's see if we have other Rinkeby accounts. So go to MetaMask. If you don't have account 2, you can create one, or you can use your MyEtherWallet account. You can log in into MyEtherWallet and take the account, and you can use it here. So I will just take this account 2. I will copy this account, and again I will change it to account 1, because account 1 is going to transfer, right? So account 1, we can see account 1 is here. We are going to transfer from account 1 to account 2, and how many tokens we want to transfer? Let's transfer 20,000 tokens. Click on this transfer function, and the MetaMask screen will pop up for confirmation. You can see 20,000 tokens we are transferring to account 2. Click on confirm. We have this Rinkeby link. Click on this link. After a few seconds, we will be able to see the status of this transaction. You can keep refreshing. So our transaction is successful. You can see here there's a new line, tokens transfers from this account starting with 00D2A to account starting with 0xB859. And how many? 20,000 tokens. So if you click on this contract address, you can see 2 transactions, and you can also see the token tracker. It's a BLK training, it's our token name, and BLTK is our symbol. If you click on this, you will see the transaction happen on this token. So total supply is 50,000, and right now only 2 addresses have all these 50,000 tokens. First address has 30,000 and second is having 20,000. So first address is this one. If you click on this, it should have the 30,000 tokens as a balance, and this is coming from the balances mapping. So if you go to the remix, this is coming from your balance mapping. So this transfer function can be used by the second account now to transfer to the third account. So if you have the third account in MetaMask, let's create one. Let's create one account 3 and click on create. It has only 0 Ether, right? Let's copy this address and let's change it to account 2 who has some BLK tokens, but with account 2 also you have to add the custom token. So how we can add the custom token here? We need to get the contract address of that token. Okay, so here we have the contract. Click on this contract, get the contract address. You can get the contract address from remix as well. Okay, now what we are trying to do is we are trying to transfer some tokens from account 2 to account 3, but account 2 will recognize that token in MetaMask only if you click and add the token here. So first you need to put that contract address. It's already done. Click on next. It has 20,000 tokens. It already pulled it, and add token. Now let's send. You can send it from here as well. So send from account 2. Let's select the third account and let's send 1000 tokens, and we can select fast. You can click on next and confirm. Click on this arrow, it will take you to the Link-B Etherscan. The same transaction you would have able to do it from here. So what you will have to change it here is the account should be your account 2, and in transfer you will write account 3, 1000 and click on this transfer. It will do the same thing. So the transaction is successful from the account 2 to account 3, 1000 tokens. If you click on this token, you will see all the transaction happen. 20,000 first time we transferred, then we transferred 1000. So total 3 address has all 50,000. So it's showing you the 3 address here. And if you go to contract, copy this contract address and go to MetaMask and check the token amount for account 3, but we will have to add the custom token here. So for account 3, click on the add token, then custom token, then you have to provide the contract address of the token, then click next. It has the 1000 tokens. So hope you have understood how this total supply, balance of, and transfer function work. Now we have to test these approve transfer from an alliance. So approve function is one account is approving other account some tokens, right? So first account has 30,000 token. What we are trying to do is we will approve some tokens from account 1 to account 3. Okay, so let's see how it will work. So we will go to this approve function. So approve function is this one. You have to enter the address of spender, which is getting the token approval. So let's copy the account 3 address, copy it, again go to account 1 so that your account 1 is coming here. And now go to approve function, paste the address of account 3, and then suppose we are allowing 5,000 tokens. So it will not transfer right now, it will just approve it. Nothing happen with the balances of from account or to account. Okay, so just click on this approve and it will go to MetaMask. Here you can see by approving this action, you grant permission for this contract to spend up to 5,000 of your BLK tokens. So confirm it, go to this link. Transaction is successful. So you can see this contract has 4 transactions till date, but nothing has been changed in the balance mapping. If you go to MetaMask, you can see account 1 still has 30,000 token, and then if you go to account 2 has 19,000 because it has transferred 1,000 to account 3, and if you go to account 3 should have 1,000 tokens. We can also test the alliance function. As we know, like alliance function is used to know the number of approved tokens by one account to another account. We just approved account 1 to account 3, 5,000 token. So let's copy account 1 and we will pass as a owner in alliance function, and then the second parameter would be the spender, that is the account 3. Let's copy the account 3 address and pass as a second argument. Now if we click on this allowance function, it will give us 5000. So our all functions are working perfectly. Now we can test the transfer from function. Since account 1 has approved 5000 token to account 3, we will try to transfer the approved tokens from account 1 to account 3. But if you see account 3 doesn't have Ether balance, which will be needed to run the transaction and pay the gas. So we will just transfer some Ether from account 2 to account 3 before we run the transfer from transaction. So let's transfer 10 Ethers from account 2 to account 3. Click on fast and then click on next. Confirm the transaction. We can see on Ring-B Etherscan, transaction is in progress. Now it's successful. Now if we check the balance of account 3, we can see it has 10 Ethers. So we can run the transaction. One thing to note here is when we are trying to do the transfer from, we want to run the transfer from function using account 3. Just to prove that if account 1 has approved something to account 3, account 3 should be able to withdraw directly tokens from account 1 and deposit to its own account. Okay, and that's why we needed Ethers, because we had to run the transfer from transaction using account 3. So copy the parameters whatever we have in allowance. Allowance we have owner and sender, and the same parameters we need in a transfer from. Just to save time, we just copied and paste. And now the third parameter is how many tokens we want to transfer from account 1 to account 3. We have 5000 approved. We can transfer 5000 or less. So let's give some 4000 and click on transfer from function. Make sure that your account is account 3, so it's a 0x7D4. If you go to account 3, it's the same address, so we are good. Let's click on a transfer from and confirm the transaction. We can see the Ring-B Etherscan link. Transaction is successful, and now if you go to account 3, it has 5000 BLTK tokens. Earlier it has 1000, now we transfer 4000, and those 4000 should be deducted from account 1. So we saw all these functions working perfectly, and you can also check the allowance function again to see how many tokens are remaining, which were approved by account 1 to account 3. So since initially the 5000 tokens were approved, 4000 tokens were transferred. So we should expect that still there are 1000 tokens which are approved and which account 3 can transfer in future. So here you can see the allowance is remaining is 1000. And one more thing I would like to show here is, like, if you go to Ring-B network and there is a filter search, here you can actually search your token. So if you type BLTK, which was our token name, you can see 2-3 since we deployed 2-3 times, but you can actually compare your contract address. So this is the latest one, 0xEA70. So if you just click on, this is our BLTK token. So it's interesting. You can actually create your token, deploy your token, and if you search, you will be able to see your token. And similar way, you can create your tokens and deploy on live Ethereum blockchain network. With this, we completed this section. Hope you enjoyed. So thank you and all the best. Welcome back. In this section, we will discuss about ICO, and we will develop a smart contract to implement ICO with our own token. So what is ICO? ICO is the short name for initial coin offering. An initial coin offering is a method of crowdfunding through cryptocurrencies and blockchain. ICO is the biggest trend in cryptocurrency today for quick fundraising. It provides token to investors in exchange for legal tender or other cryptocurrencies such as Bitcoin or Ethereum. ICOs provide a means by which startups can get funding for their project. ICOs has raised over $17 billion in 2018 alone. We can see the ICO tracker online, like there is one website called coindesk.com. So here you can get the data of ICOs. Various ICOs happen in last many years. So if you go to this size versus number of ICOs, you can see like in 2018 alone, it's over $16 billion. And first ICO was held by Mastercoin around July 2013. In mid 2014, the Ethereum Foundation sold ETH against 0.0005 Bitcoin each. They received nearly $20 million crowdfunding as the capital base for the development of Ethereum. It doesn't mean that all ICOs are successful. Nearly half of all initial coin offerings in 2017 and 2018 failed to raise any funds, while another 40% raised more than $1 million. Anyone can run ICOs, but before running ICO, it is mandatory to follow the rule, regulations, and laws of the investors' countries. So, not all ICOs are genuine. There have been many ICO scams. So, hope you get the idea what is ICO and how it can be used for quick fundraising for your project and business. Using ICOs, you will distribute a token, and in exchange of those tokens, you will get the investment from your investors. It works like a share. So, you are giving your share of your company to the investors. So, that's all in this lecture. In next few lectures, we will create a smart contract for ICO. We'll deploy and test on live Rinkeby blockchain network. Welcome. In next few lectures, you will see how we can develop our ICO smart contract, and then we can deploy our smart contract on Rinkeby network, and we will do some testing. So we will develop our ICO smart contract by inheriting our ERC20 token contract, which we developed in last section. So what we can do is we can actually copy all these codes just to keep a separate SOL file. Go and create a SOL file called ICO and paste all the codes. And we can actually change this coin. If you want to have some other name of your coin, you can change it here. Let's write BLKTR, and you can also change it like block training. One thing to note here is when we inherit this smart contract, we will just deploy our ICO smart contract, and that smart contract deployment will take care this smart contract as well. We don't need to deploy ERC20 token contract. If you deploy the smart contract which is inheriting any other smart contract, then you are good. You don't need to deploy every contracts. At the end of this contract, define a contract. We can give the name as ICO block, and it will inherit our ERC20 token smart contract, and the name of our ERC20 smart contract is my ERC20 token. So just copy it and we can just paste it there. So in this lecture we will define all our state variables, we can define modifier, and we can also create our constructor, and in next lecture we can create a function which will take care of the investment. So what all state variables we need? First, we need to define the admin of the ICO. Who will launch and end this ICO? How we can define? We will define as address public. This is the address which will deploy this ICO contract, and we will consider that address as an admin of this ICO. So we can write here administrator. Okay, and we need an account where the ethers or funds will be deposited whenever we will get the investment from our investors, and that account should be address payable. So let's define a deposit account, or we can say recipient account. So we will define address payable recipient. We need to set initial price of token, because when we will distribute our token, we want some investment from our investors. So how much investment they will do? Suppose we price one token 1 ether, and if the investor invests 100 ethers, so that investor will get our 100 token. So we can define a variable. It will be unsigned integer, where it will, because this will be the amount. So public, we can take a name as token price and equal to what price we want to set. Let's set to 0.001 ether, and 0.001 ether would be around equal to, what we can go do is we can go to ETH converter. There are many online websites you can find in Google where you can actually convert your ethers to Wei. So in our smart contract we have to provide the amount in Wei. So we are going to ethconverter.com. It's eth-converter.com. Here if we write 0.001, we will get the Wei. So let's copy it and go to our smart contract, and we can just paste it here. So this is a price of 1 token. Every ICO should have one hard cap when you will say like, okay, my ICO is successful. Okay, and you will stop your ICO. And there may be one soft cap as well. Okay, suppose you are running an ICO, you want like, okay, if I get 300 ethers, that means I can say like I'm successful. And if I get 400 ethers, then I'm done. I don't want more investment, and that's my hard cap. So soft cap is like, okay, your ICO is successful, and the hard cap is we are done. We don't don't want more investment and we have to stop our ICO, and then we will stop our coin offering. And let's define the hard cap is like 500 ether. So once we will get the 500 ethers, we will stop this ICO. So again, go to converter.com. Here if you write 500, it will give you the ways and you can actually paste it here. So let's define unsigned integer public ICO target. So this is our hard cap. We will define a state variable as well to track the funded amount, like how much investment we get. So we will just track it. So let's define here what we are going to define a state variable to track the funded amount. So let's define unsigned integer public and we can give the name as received fund. We will also set the maximum allowed investment. It will limit the investment per investor, and also we will set minimum allowed investment, the amount which each investor will have to definitely invest. So let's define two variables, maximum investment and minimum investment. And max investment we can have 10 ethers, and minimum investment we can have like a 0.001. So at least one token investment we want from investor, minimum investment. Let's go to ether converter and write here 10 and it will give you the ways. Copy it and then paste it here, max investment. And now minimum investment we want 0.001. that's the token price for one token, so that's what we want. So we have defined most of our state variables. There will be functions in this contract which will be executed only by admin. So let's create a modifier first. So here we have created a modifier and we are checking if that caller is administrator. So there will be functions like to set the status of ICO. If you want to stop the ICO or resume the ICO, then that will be done by admin, right? So we want a modifier and we can use that modifier in our functions. Now we will save the address of administrator and recipient address in constructor. So let's define a constructor. First we will save that administrator. So whoever will deploy the contract will get that address in message.sender, and that we are saving as administrator. We also need a address where all the funds will go. So the contract owner who is going to deploy this contract can actually provide this recipient address, and that address will be address payable, and this is the recipient address where we are saving. So we can write recipient equal to underscore recipient semicolon. So here we are done with our most of the state variables. We need few more state variables which we'll see in next lectures. As we need, we will define the state variables here. So at least we have our basic state variables, modifier and constructor. In next lecture we will define function which will be used for receiving fund and distributing the tokens. Welcome. In this lecture, we will define function which will be used for receiving fund and distributing token. And that function will be payable because we are receiving the ether. So create payable function. We can name it as investing. It will be payable, public, returns, and it will return success flag after execution of all the lines of code. When an investor will call this function to invest, then we will need to calculate how many tokens we need to give to investor for the investment. So we will have a simple math here. To find out how many tokens can be given to investor based on investment, we will define an unsigned variable to store the number of tokens investor will get. So let's define unsigned integer. We can name it as token. It's a number of tokens which investor will get. So how many he will get? Message.value will have the amount he is investing, and we can divide this amount by the token price of one token, and it will give you the number of tokens we have to give to investor. Suppose the message.value is 200 ethers and our token price is half ether. Then he will get 200 divided by half. That means 400 tokens. Now to give these tokens to investor, we just need to write it in balances mapping table. So we have this balance mapping table here in our my ERC20 token contract, which saves the address and the number of token that address holds. So we can just write one entry in that mapping table and that address will get those numbers of tokens. So we have the balance mapping, balances, and then we will have the message.sender who is the investor, and we can actually do plus equal to this token. For this investor, we will write one entry in our balance mapping. Key will be the investor's address and we will add the token. Why we have done plus equal to? Because this investor can again come and invest. So we will just keep adding the number of tokens he is eligible for based on the investment. Now, if we have added the number of tokens with the investor, so we will have to reduce the same number of tokens from the creator who initially has all the tokens, the founder of this ICO. And the creator is defined here in our ERC20 token contract. So let's subtract the same amount of tokens from creator's account. So what we can do, mapping name balances, creator as a key, and then subtract and then minus equal to tokens. Now we have to send the money whatever we have received to our recipient address, recipient account. So how we can do it? We will use the transfer member of address payable. Here address payable is recipient dot, we will write transfer and in bracket how much amount we are transferring, and that amount is this message dot value what we are getting from the investor. So we got the money, we calculated the number of tokens investor is eligible for, then we added the tokens with the investor address in our mapping, then we have reduced the same number of tokens from the creator, and then we transfer all the money we have received from investor to our another account which we have defined as a recipient account. We have also defined one receive fund state variable to track our deposits. So we can actually write here receive fund plus equal to message dot value. Every time investors will call this function, we will keep adding all those funds in our receipt fund, and finally we will return true. So this is the basic functionality of receiving the funding and allocating the tokens to investor. So we can actually test this contract. So we don't have any compilation error, so we can go and deploy this on our Ring-B network. So make sure you have the injected web3 selected here, and in MetaMask you are logged in with the Ring-B test network. We have account 1 with some ethers. So if we just refresh this screen, it should load that account. Okay, so we can see the account here 00D2, and in MetaMask also it's 00D2. Okay, so this is our administrator and this is also a creator, because this will be our message.sender and we are going to store these in our contracts as administrator and also as a creator. And here we are just going to deploy the ICO smart contract. It will take care of ERC20 also. So we have given the new name to our token, so it will create a new token in Ring-B network. But in constructor we have to provide the recipient address. So what we can do is we can take the another address from MetaMask where we can actually receive all our funds. So create another account for recipient. Let's give it recipient account. We can keep it account 4 or you can give the name. So this is the account where we will be deposit all the investment, copy it and again change it to account 1. So account 1 is our administrator or creator. So initially all the tokens will be with this account. So paste what we have copied, the recipient address, to the deploy, and it will take care by the constructor. Click on deploy. MetaMask screen will come. Confirm this. We will get the Ring-B link. Click on the Ring-B link, and after a few seconds we can see the status of our transactions. So transaction is successful, our contract has been created. Copy this contract address and go to MetaMask and first add this token in your MetaMask. So what you can do, click on this add token, custom token, paste your contract address. You can see the new token has been added, and this creator has so many tokens whatever we have in our contract, ERC20 token contract, the initial supply, add tokens. Same thing we want to do with all our recipient accounts, or another account. You can see account 2. We will use the account 2 as an investor account. So let's do the same thing here. Right now account 2 has 0. Let's do the same thing with account 3. Account 3 will have a second investor, and we can do the same thing here. So right now account 2 and account 3 have 0 tokens and account 1 has all the tokens. We can see here the tokens BLKTR. It's already created. Now what we want to do is we want to invest. We will invest some ether from account 2, and if our function is working correctly, this account 2 will receive the token as well. So let's in MetaMask change it to account 2. It is changed here. Now suppose this account is investing 5 ethers. Okay, so we have the creator here. You can see D2, and creator should have all the tokens, 50,000 initial supply, and administrator is also the same person. So now we are interested in our investing function. So second account is investing 5 ethers. Click on invest button. MetaMask screen will come, and then confirm this transaction. We have this Ring-B link. Click on this. After a few seconds we will be able to see the status of our transaction. So our transaction is successful. Now if you go to Remix and check the balance of this account, this 0xB85 is our investor, but our recipient is this account. Now if you go and check this recipient fund, we should be able to see the 5 ethers. Yeah, this is the 5 ethers which was invested by our investor, that is account 2. And this account 2 should have received the tokens. So let's go to MetaMask. Here also we can check actually. If you just copy it right and go to our balance mapping. Where is our balance mapping? Here is the balances. So earlier the creator has 50,000. If you click again for this creator, you see the 5,000 has been deducted, and those 5,000 tokens should be with the investor. So investor invested 5 ether, and with 5 ether, based on our token price, one token is 0.01 ether, we will get 5,000 tokens. So our investing function is working, our constructor is working, but right now we have actually not put any check on maximum investment, minimum investment, or the hard cap. So in next lecture we will put some checks here. So I'll see you in next lecture. So in this lecture we will set checks for hard cap, minimum and maximum investment. And we can put the checks in our investing function. So we can implement a logic with require to reject the investment if sum of total received amount and current investment, that is the message.value, is greater than equal to ICO target. So for an example, if ICO target is 500 ethers and we already received 400 ethers as investment, which is in our receipt fund, and if a new investor is trying to invest 200, so what we will do, we will add 400, which is in our receipt fund, plus the 200 which we are getting as a message.value, and we will compare it with our ICO target, that is 500. Since 400 plus 200 equals to 600 is greater than 500, our ICO target, we will not allow the investor to spend because we have already reached our hard cap. So we will write ICO target and we can give a message here. So this is the check for hard cap. Now let's also put required check for minimum and maximum investment. So here we will be comparing the investment we are receiving by the investor, that is message.value, with our minimum investment and maximum investment variables. So if the message.value is greater than minimum investment and message.value is less than equal to maximum investment, only then it will be allowed. Otherwise the error message will go out. So we are all good with the checks now. In next lecture, we will set the status of ICO, like when the ICO is active, when it is completed, or if by any reason administrator wants to stop the ICO, how he can stop the ICO. And after stopping the ICO, if the administrator wants to resume the ICO again, how the administrator can set the status to resume the ICO. Welcome. In this lecture, we will set the status of ICO, like when the ICO is active, when it is completed, or if by any reason administrator has to stop the ICO, and again if administrator wants to resume the ICO. And the investment will happen only when ICO is active, and we can implement this logic with the use of enums. So let's define one enum and set the possible ICO status. We can write enum, then we can give the name as status, and then we can give our values of status. So it may be first, it may be inactive and active, stopped, completed. That's enough. We don't need a semicolon with enum, so we can now define the enum variable. So as you know, when you define a enum, we can use this enum name, that is your status, as a data type, and you can actually define a variable name for this data type, and we can give the name as ICO status. We also need to define ICO start time and ICO end time. So when the ICO will be starting and when it will be ending. So it is not necessary when you deploy your contract at the same time it will start. You can set up like after 7 days of deployment you want to start your ICO. Since we have to do the testing right now, so what we can do is we can define a variable called ICO start time and set the ICO start time as now. So we have already gone through this now global variable in our previous lectures. So now means whenever this contract will be deployed, that time we can make our ICO active. And similarly, we need one end time, and we can run our ICO for whatever days you want. Suppose if you want for 5 days, okay? So 5 days. This is your duration. So here you need to give now plus, you cannot write 5 days. Now plus the seconds in 5 days. You can actually calculate online, say how many seconds will be there in 5 days. So I have the number 43,000 seconds will be there in 5 days. So this ICO will run for 5 days. Now we have the enum status. So we can write one function. Let's after constructor, let's write a function to set the status of ICO to stop. So suppose by any reason our administrator wants to stop the ICO. So he will set the ICO status as a stop. How the administrator can do it? So create a function called set stop status, and it will be done only by the admin. Here we can use our modifier owner only, and then open the brace, and here we can set ICO status equals to status dot stop. And again, to resume the ICO, we can have another function, and it will be run by only administrator. So we can use the modifier, and again we can write here ICO status equals to status dot. So this is for emergency purpose. Administrator can stop and active. But how we can use these status? Actually, in investing function, you can check the status. What is the status? If it is active, then it will execute all the lines of codes. If it is not active, it will not execute these lines of codes. But there are many status, right? So ICO can be stopped, ICO can be active, ICO can be inactive. Suppose you set the start time after 5 days of deployment. So for those 5 days, it will be inactive status, right? So that time also you cannot allow investment, and also there will be a status as completed. So once the ICO is complete, no one should be allowed to invest. So investing function needs to know what is the status. So we can actually create a function to get the status. What is the current status? So let's create get status function, and we can make it public, and it will return the status. We can just put simple if conditions. If ICO status equals status dot stopped, then return status dot stopped. Else if block timestamp, we can use block timestamp here, is greater than equal to ICO start time, and block timestamp is less than equal to ICO end time, then our ICO should be active. Again, else if block timestamp is less than equal to ICO start time, that means our ICO is not active. So we can return status dot inactive. That is, our ICO has not been started actually. And finally, else we can return completed. And we can call this function. This is returning status, so we have to write here status variable name, and it will have whatever value we are getting from our get ICO status function. So hope you are understanding this thing. We are first getting the ICO status. If the ICO is active, only then these lines of code will execute. If it is not active, we will not execute these lines of code. So we have to add the required check here on this ICO status. If ICO status equals status dot active, only then it will execute following lines. Otherwise, you can give the message like ICO is not. So here we are done with the status. In next lecture, we will see how we can burn the unsold tokens from creator account so that it can't be misused. So burn means here the creator has 50,000 tokens, okay? And suppose by end of ICO, he distributed only 40,000. So he has remaining 10,000 tokens. Those 10,000 tokens, we should actually burn. We should remove from the system. The creator should not have those things. Otherwise, it can be misused. We have already tagged the price with every tokens. If 40,000 tokens distributed, that means that company has those 40,000 tokens with the investors. So in next lecture, we will write a function to burn those unused tokens. So welcome. In this lecture, we will burn the unsold tokens from the creator's account so that it can't be misused. So what we can do is we can write a burn function. You can give the name as burn public returns bool and open the brace. You can also add the modifier. So first we will check the ICO status. Once the ICO is completed, only then we will actually burn all the unsold tokens. So we can write ICO status equal to get. We have to give just one equals because we are assigning the values what we are getting from get ICO status function, and then we will add a required check, and here in this required check we will have ICO status double equal sign, which is the compare sign, status dot completed. So if ICO status is completed, only then burn all the tokens. Otherwise you can give a message like ICO not completed, something like that. And then how you can burn? So we can just set the value as a 0 in mapping table for the creator, and it will burn all the tokens. We just need to set a 0 value for the creator address in our balance mapping, because balance mapping has all the address and how many tokens that address has. So we can write balances and then creator equals to 0. So it will burn unsold tokens when the status is completed. So we can give the modifier as owner only. So administrator can only do it. So that's all in this lecture. We can also add one more feature in our contract when we want to allow our investor to trade the tokens. So definitely until the ICO is active, we don't want the investor to trade those tokens whatever they are receiving for their investment. That can impact the token price, the market value. So what we can do is we can set a time when the trading can be started, like after ICO end or after 2 days of ICO end or 7 days of ICO end, something like that. So in next lecture we are going to implement the logic for trading. Trading is nothing just to transfer the tokens from one account to other account, but when those can be allowed, that's also we need to implement. In this lecture, we will restrict the trading of tokens until ICO is in progress or for a specific duration. When an account invests, that account will receive tokens, and to make profit, that account can start trading the tokens, which can impact the ICO and token price. So we will put a logic to restrict the trading of token until ICO is in progress or for a specific duration. So we will define one state variable for trading start time. It will be unsigned integer again, and we can give public start trading, and you can actually give ICO and time, plus you can have like suppose 5 days or 7 days. So 5 days is 43,2000. So I'm just commenting it, and again I will write the same thing here, but why I have commented is I don't want this 43,2000 right now because we are going to test it. So if we will give 432,000, then we will not able to test this functionality. We will have to wait for 5 days, right? But this is how you can actually set the duration for your ICO and when you will allow the trading of tokens by the token holders. A token holder can do the trading using the transfer function. Trading is what? He will transfer the tokens to other address, other party, right? So that transfer function we have in our ERC token contract. This is the transfer function. We can just copy it. We will have to add some restriction in this transfer function. And what we can do is we can just copy this transfer function here, and we will override this transfer function with the restriction. So we can go and copy this. We can paste this here, and now we can add the required check to check that the whenever this transfer is happening, that time is greater than equal to start trading time. And that check we can put it by using this require. We can have require block.timestamp is greater than start trading. Only then we will execute the lines of code of transfer function. And here we don't need to write all these codes of transfer function. What we can do is if can just write here super dot transfer, and then we will just pass our to and value. That's it. It will go and run the lines of code whatever here in this ERC20 token contract, but we are getting some error here. So because we have defined as external, so let's change it to public. Okay, and here also we can change it to public. Since it's external, that's why it inherited function is not able to call it, so you can make it public. Okay, so this is an optional function. You can add it in your ICO. It's on you. We are getting some warning because we are not returning the flag, so let's return true. So our contract is ready, but we have another function transfer from, which does the almost same thing as what we do with the transfer, right? So we should have the same logic implemented with this transfer from function as well. So let's copy it and paste it here. We can have same lines of code here. Only difference is we have to change it to transfer from, and we also need to pass from underscore from. And again, this is again external. We have to make it public. Here also, let's see if it is external. It's external. Let's change it to public. So we are all good now. So we have defined our start trading time, and right now it's like as soon as the ICO will end, token holders can do the trading. They can transfer the tokens to each other, but you can definitely add the duration when you want to start. So I have not added it here because we need to test it in Rinkeby, and we don't want to wait for 5 days to test our contract. Otherwise, you can just add 10 seconds, 60 seconds, and you can check your functionality. So now we are done with our smart contract. In next lecture, we will deploy this smart contract on Rinkeby network, and we will test all the functionalities. So in this lecture, we are going to deploy our ICO smart contract. We can change our token symbol because we already deployed this smart contract before just to test our few functions, and we have also transferred tokens from one account to other account. So let's change this name to something else. We can give the name as BLKTRN as our new token, and then we can deploy on Ringby network. So make sure you are logging into MetaMask and select account 1, or you can select any account. Let's select account 1 as a creator and administrator of the ICO. Now in our remix we should have that account here. So first account is 00D2. So first account starts from 00D2, and here we have the same account. So let's clear all these earlier deployed contract from this screen, and now recipient address. So recipient address, we can have our another account created. Since this recipient account already had 5 ether, I want to create another account to test this smart contract freshly. So let's create a deposit account. Give the name as deposit account. Okay, deposit account. So all the investment will go, whatever funding we will receive will all go to this deposit account. So copy this and again change to account 1, which is our owner of this contract and administrator or founder of the tokens. Here we can go and paste this deposit account address. So constructor will save that address in the recipient address state variable. Confirm the transactions. Now we should have one link here. Click on this link, and after a few seconds we will have the status of this transaction. So our smart contract deployed successfully. This is the contract address. Let's copy this address, and we are going to add the custom tokens to all the accounts. So click on this menu item, click on this add token, custom token, and then paste the contract address. So we can see the BLKTRN, our token symbol, the new token. Click on next. All tokens are with this account, add tokens. So account 1 has all 50,000 tokens. Same thing we have to do with all the accounts. Account 2 and account 3 we will consider as an investor. So add the tokens with account 2 and account 3 as well. We'll go to account 2, click on add token, custom token, then paste the contract address. It will pull the BLKTRN. It's 0 right now. Do the same thing with the account 3. Go to menu, click on add token, and then custom token, paste the contract address, and next add tokens. So account 2 and 3 have 0 tokens. Account 1 has all 50,000 tokens. From account 2 we will invest something. Okay, so account 2, you have to select the account 2 in MetaMask, because account 2 will call the investing function. This investing function will be called by account 2. So we have the account 2 address here. Suppose account 2 invests 4 ethers. Okay, so you can click on this investing now. MetaMask screen will come, and this is 4 ethers which account 2 is investing. Confirm, and let's go to Ringby Etherscan. Wait for a few seconds to get the status. Our transaction is successful. If you go to Remix and go to MetaMask, here you should have the account 2 should have the token 4000 tokens. So account 2 invested 4 ether. Our token price is 0.001. So 4000 token it received. Now if you check for account 1, it has 50,000 token. Now it should have 46,000 token. Same thing you can check from here. So we have this address of investor. If you copy that and paste it here in the balance, this is the balance mapping getter, and it will give you 46,000. This is the account 1. We should have the account 1 in MetaMask. Yes, this is the account 1. If you select the account 2 and copy this will change here, and again if you paste that address to the balances function, make sure you're pasting the account 2 and then click on balances. You have the 4000. Now let's transfer from account 3. So you have to select account 3 here, and then your account 3 should be here in account. Let's enter 6 ethers and click on investing. MetaMask skin will come. Confirm the transaction. Go to the Ringby link, and then after a few seconds we'll have the transaction status. Our transaction is successful. So if we check the account 3 balance for tokens, we can see the account 3 received 6,000 tokens, and the same investment should go in your deposit account. So if you go to deposit account has ethers. So similarly we can actually test these functions, transfer or transfer from, but just to make sure when you are testing this, your block.timestamp is greater than start trading. Okay, we have made the start trading as ISO end time, and ISO end time is now plus 5 days, so we will not able to test it. So just for your testing purpose, we can make it now. We will have to deploy it again. So let's change the token ID again just to do the fresh testing for this transfer function. And what we will do in our contract, we can just add 1 and we will deploy it, and recipient address is our deposit address, right? So let's create another account. We want to have a fresh account here just for testing purpose, otherwise you can use the same deposit account. Let's give ICO deposit account, create, and right now ICO deposit account has 0 ether. Change it to account 1. So account 1 is our creator and administrator, make sure we have this, and then copy the ICO deposit account address and change it to account 1 again. Go to remix and paste the recipient address with the deploy. Click on deploy, confirm the transaction. After a few seconds the transaction will be completed. So transaction is completed. This is our contract address. So let's copy this contract address, go to MetaMask. We have to add the custom token. So what we will do, we'll click on menu, click on add token, custom token, enter the address. The token symbol came as BLKTRN1, and next add tokens 50,000 initial supply with account 1. Do this with account 2 and 3 as well. Click on add token, custom token, enter the address, next add tokens. Click on account 3, add tokens, custom token, give the address, next add tokens. So now what we will do, as an account 2 investor, we will go and invest some money. So we have selected account 2 here. Now what we will do is we will pass some 7 ethers and investing. MetaMask skin will come, confirm, and let's go to Ether skin. And is successful. If you go to remix, or we can just copy this address and go to balance and paste this address, you can see the 7,000 ether it got based on its investment of 7 ethers. Same thing we can do with the account 3. Account 3 can be an investor. We can select the account 3 here, and that account should come here 7D, and again suppose account 3 is investing 8 ethers. We can enter 8, click on investing, and then confirm. Oh, it has insufficient fund because account 3 has only 3.99 ether. It's a good check. Let's invest only 2 ethers. So investing, and then click on this MetaMask confirm screen, go to ring B. After a few seconds we can see the transaction status. So transaction is successful. If you go to MetaMask and see the account 3 token balance, which we should see 2000 token because 2 ether was the investment, and for account 3 and account 2 should have 7,000 tokens. Now we have the another function here, the transfer function, the trading function, right? So let's test the trading function. We have to just test the transfer here. Suppose account 2 is sending some tokens to account 3, then it will call the transfer function. So either you can do directly from MetaMask, you can select the token and click on this send button and select the account 3 and enter some tokens, suppose 500 tokens, right? So you can send from directly from here. Select fast and click on next and then confirm. We'll have to wait for the transaction to be completed. Go to ring B Ether scan, wait for a few seconds. So transaction is successful. That means we have successfully transferred 500 tokens from account 2 to account 3. If you go to account 2, now it should have balance of 6500, and if you go to account 3, it should have balance of 2500. Initially it got 2000, and then from account 2. All these things you can test it from here. If you go and click on this contract, you can see your token here listed here. Okay, if you click on this block trend, it will show you which addresses has the token. So 2 addresses has participated, our investors. So this is our 500 quantity. Last transaction happened in this transaction. Okay, so this is how you can create your ICO smart contract, test all the functionalities. You can add as much as you want. As a best practice, you should also use the safe math. There is a safe math smart contract. Safe math provides you protection from the overflow of unsigned integer calculations. So if you Google it, safemath.sol, you will find that safe math, and you can import that to when you are deploying in your production or making more secure a smart contract. You can use the safe math functions, and like here the token equal to message dot value divided by token price. So sometime it may overflow Okay, so those things you can handle with the safe math functions, and that is a separate contract already written, and you can import that smart contract in your ICO smart contract to be more safe and secure. So hope you understood how you can create your ERC token, how you can create ICO smart contract, and how you can launch, how you can set the timing, status, everything. So I would recommend implement it, do the thorough testing, add more and more features if you want, and you can actually use this for your business funding. If you have any plan to start your business and you want investment, you can actually use this for fundraising. Hope you enjoyed it, and that's all in this section. Thank you.